Hello students, I will be now discussing 7.07, that is using radioactivity. Okay, so let's start. Radioactive isotopes are called radioisotopes. Some are produced artificially in a nuclear reactor by bombarding other isotopes with neutrons. Here are some of the uses of isotopes, radioisotopes. Okay, so we have some of the uses of radioactivity, that is we use radioactivity for some of the good purpose also. Okay, it is used in tracers and it is used in also radiotherapy. Okay, let's start with tracers. Radioisotopes can be detected in small and safe quantities, so they can be used as tracers. Their movements can be tracked. Here are some examples. So radioisotopes can be detected in a small quantities and can be used as tracers, and their movement can be tracked. Checking whether patient's thyroid gland is taking in iodine properly. The patient drinks a liquid containing iodine 123. A gamma emitter. A detector measures the activity to find out how quickly iodine becomes concentrated in the gland. That means we can use these tracers in a patient's thyroid gland to check if it is taking at the iodine at a right properly or at a right amount. That is, the patient will drink the liquid containing iodine 123, and a gamma emitter detector measures the activity to find out how quickly iodine becomes concentrated in the gland. That means how it ionizes there. Okay, so detecting leaks in underground pipes. That is by adding tracers to fluid in the pipe, It can be also used to find out the leaks. That is we have underwater pipe. That is if there are some leaks, it can cause harmful effect. So to find out the leaks, it is impossible to find out the leaks at blind eye. So we use that is detecting the leaks, we use the tracers. Okay, we use the tracers in case of detecting the leaks for a water pipe, that is underground pipe. Okay, and then we repair it. Okay, now using of radioactivity in radiotherapy. Okay, gamma rays can penetrate deep into the body and kill living cells. Okay, it can kill living cells. So a highly concentrated beam from a cobalt-60 source can be used to kill cancer cells. Treatment like this is called radiotherapy. So you already know about radiotherapy. That is, radiotherapy can be used for cancer patients to kill cancerous cells. So gamma rays can penetrate deep into the body and kill living cells. So a highly concentrated beam from a cobalt-60 source is used to kill the cancer cells, and this process is known as radiotherapy, where you can treat patients those are having cancer disease. Now, while choosing radioisotopes for a particular job, you must consider two factors, that is the penetrating effect and half-life. Okay, penetrating effect, that means gamma rays are very penetrating, beta particles are less, so the alpha particles are least of all. Okay, gamma rays have the most penetrating power, and beta have less, and alpha particles is the least of all. So you have to leave alpha, and you have to choose between beta and gamma by seeing the conditions of the application. Okay, and half-life, you must choose radioisotope with shorter half-life, because a short half-life reduces the time that living cells are exposed to harmful radiation. That means if you use radioisotopes with short half-lives, they will left no harmful effect to the living patient. Okay, the harmful radiation will be exposed less. Okay, will be exposed less to the patient. So using radioisotopes with short half-lives is useful for the patient, that is they cause less harm. Okay, they can they cause less harm, and we can also ensure that the patient is no longer exposed to high amount of radiation. Okay, that's why we must use a radioisotope with shorter half-life. And now thickness monitoring. Okay, how to monitor the thickness, that means if any tire cord or that is plastic pipe, how they're evenly made, or the thickness, how the thickness are evenly made. This is the way of thickness monitoring. We also use radioactivity there. That means if the thickness is more, the setup is like this. It goes to a roller, beta source is in the upward and the detector here. If the thickness is more, the detector will detect beta less, and if the thickness is less, the detector will detect beta more. Okay, and if the thickness is constant, the count rate will be same throughout the roller. Okay, so this is a way to ensure that the thickness is same throughout a tire cord. So if the thickness is more, the detector will detect less beta. If the thickness is less, the detector will detect more beta, and if the thickness is constant, the count rate or the detector reading will be the same. Okay, now testing for cracks, that is gamma rays are like X-rays. Okay, so they can be used and photograph metals to reveal cracks. A cobalt 60 gamma source is compact and does not need an electrical power source, unlike an X-ray tube. Okay, that is gamma rays are like X-rays, so they can be used to photograph metals to reveal cracks. That means we can test for cracks using gamma rays and X-rays. A cobalt 60 of the gamma source is a compact and does not need an electrical power source, unlike X-ray tube. Okay, so cobalt 60 is a gamma source which does not need an electrical supply. And here dating rocks. Okay, dating rocks and carbon dating are the two topic for the topic here. I will tell you a short summary on this. That is, dating rocks. What are dating rocks? When rocks are formed, some radioisotopes become trapped in them, but the time goes, the radioactivity slowly dies away. This idea can be used to estimate their age. For example, potassium-40 is trapped when molten material cools to form igneous rock. As potassium-40 decays, more and more of its stable decay product argon-40 is created. Provided none of this argon gas has escaped, the age of the rock, which may be hundreds of millions of years, can be estimated from the proportion of the potassium-40 to argon-40. Okay, so we can found a trace of potassium-40 in igneous rock, and also in addition of argon-40. And why this is so? Because argon-40 is a product of the decay of potassium-40, and by examining two proportion, the scientist can measure the age of a rock. Okay, igneous rock can also be dated with proportion of the uranium to lead isotopes. Okay, so if uranium decays, it also forms lead. That is, lead is the product of a series of decays start with uranium. That means if uranium decays, it also form lead. Since we have seen that potassium decays, it gives out argon-40, and here also, like, if uranium decays, it gives out lead. Okay, so this is an dating rock, and we'll now discuss about that carbon dating. What is actually the carbon dating? Scientists really use this carbon dating to measure the age of the materials. That is, there is a carbon in the atmosphere, in carbon dioxide, and in the bodies of living things. A small amount of radioactive carbon-14 is continually being formed in the upper atmosphere. While plants and animals are alive, they absorb and give out carbon as they feed and breathe. Okay, breathe. So the proportion of the carbon-14 in their bodies stay the same. That is, when living things are alive, they have carbon-14 in their body which remain constant, and when they die, and the look here, but when they die, no more carbon is taken and the proportion of the carbon-14 reduces, because of the radioactive decay by measuring the activity of the sample. And by measuring the activity means if you measure the activity of the carbon-14, you can measure the half-life or the age of the material. This is known as carbon dating. Okay, it can be used to find the age of the organic material such as wood and cloth. Okay, so you can use carbon dating to find out the age of the ancient things, that means the living things or the dead things, by checking their bones, because carbon-14, when animals or plants die, they starts to decay, and the activity, and by measuring the activity we can find out their age. So I hope you are clear with this video, with the lecture. If you have any problem regarding this chapter, please let me know in the comment section. Okay, stay safe.